Hello, Korea. Hope you all are doing very well. I love this screen. I was thinking that I want this screen in my apartment, but I think it's actually larger than my apartment is. So anyway, I'm really excited to have everyone here today. My name is Michael. I'm one of the authors of Firebase Performance Monitoring and Firebase Crash Reporting. So this year at Google I/O, we launched the beta version of Firebase Performance Monitoring. I had already been working on this project for some time already, so I was super excited to finally be able to talk about it in public. Since launch, we've had thousands of apps integrate our SDK and improve the performance. We're working on this product all the time, so you should expect some more in the coming months. So with that in mind, I want to share with you the story of an app developer named Jane. Jane is the lead mobile developer for an e-commerce startup. She's getting ready to launch her app. Building a high-quality app is very important. In a recent analysis of Google Play Store reviews, we found 50% of one-star reviews mention app stability. Firebase lets a test your app on a variety of devices before launch. And of course, no amount of testing will catch all the issues, so it's important to monitor your app in production after you launch. We'll do a quick overview of testing and crash tools, and then we'll do a deep dive on performance monitoring. Just for clarity, when we say performance, we mean the performance of your app's code, not the business performance. For that, you can use Google Analytics for Firebase. So Jane needs to test her app. They've been so busy coding that they haven't had any time to write automated tests. They've just been manually testing on a few devices. And that's where Firebase Test Lab comes in. Test Lab is a device lab running physical and virtual devices on the Google Cloud across many different API versions, even the latest developer previews. She can even choose 172 different languages to test her app on. And the best part is that we've built an intelligent app crawler called Robo that automatically explores your app and attempts to find crashes and layout issues without writing a single line of code. But you can write test scripts if you want. So Jane can upload her APK, and as Robo crawls through the app, it records a video of what it's doing, takes screenshots, captures the device log, and even stack traces for any crashes it might encounter. This lets her check her application on a real device without writing a single line of code. So just before I/O, we launched a new feature of Firebase Test Lab that's similar to Firebase Performance Monitoring. Whether you're using Robo or your own test scripts, you'll be able to see CPU, memory, FPS, and network performance alongside a video of your test runs. The great thing about this feature is that the metric timelines are synced with the video. This means that if you see a CPU spike or a drop in frame rate, you can click on the timeline, and the video will sync to that same point in time, and you can get an idea of where to investigate. So Test Lab can help you before you launch your app, but we're going to talk about monitoring performance after you launch. So she's interested in knowing when her app crashes in production, and for that, she needs crash reporting. So last year at I/O, we introduced Firebase Crash Reporting, and last fall, we integrated with Google Analytics for Firebase, so you can see exactly what was happening in your app just before the crash occurred. So I want to mention Fabric. I'm sure many of you use Fabric. We're really excited about Crashlytics from Fabric because it's the leading crash reporting service on the market. In the future, you can expect to get the Crashlytics experience right from the Firebase console. If you're thinking about integrating a new crash reporting service, we recommend Crashlytics. We will continue to support Firebase Crash Reporting if that's what you use. And in the future, you'll be seamlessly upgraded to the new experience right in Firebase when it's ready. So finally, Jane wants to understand what parts of her app are are slow, and why. And these are often the hardest issues to diagnose. The problem gets even harder when you're diagnosing issues in production. So she's going to use our brand new service, Firebase Performance Monitoring. So we'll see how Jane uses performance monitoring to progressively improve the performance of her app over a month. In some instances, Jane will use out-of-box technology, and in others, we'll see how she uses custom instrumentation to help her find a solution. All right, so we'll get back to Jane in a second, but I want to mention why we build Firebase performance monitoring. And quite simply, the world has a short attention span. Looking at data from the web, we know that the longer a page takes to load, the more likely it is that they're going to leave. And the same thing happens on mobile. As a matter of fact, 60% of 5-star reviews we see on Google Play mention speed, design, or usability. So we know that good performance is critical for success. And on the web, we have page loads, which tend to map really well to user interactions. So anytime you get a performance metric, you have a good way of mapping into what the user was doing on your website. We don't have the same types of interactions on mobile, so it's a difficult problem. And we did our best to give you the tools that you need to identify performance issues. And the result was Firebase performance monitoring. Firebase performance monitoring is still in beta, but hopefully out soon, and I'm actually in charge of a key part of that. The SDK supports both iOS and Android, and can be easily installed using the CocoaPod or the Gradle plugin. Even if that's all you do, you get a lot of value just by installing the SDK. Data like automated network traces, which is actually the feature that I wrote, and app startup. But if you want to instrument things that are specific to your implementation, we also give you the APIs to do that. That's the SDK, and the other part of performance monitoring is a console that allows you to dig into the issues and understand the performance metrics from the point of view of your user. So going back to Jane's story, we have a video here that demonstrates interacting with our app. And we think that this video generalizes to any kind of app. And we also think that performance issues can generally fall into one of two categories. And the first one has to do with your app code performance. So this is like delays your user's experience as they interact with the app, or frame drops that they see during animations. So to monitor that, we built a feature called traces. The other category of issues is network activity between your apps and the backends that it uses. Whether it's your own backend or the backends of third-party SDKs, we automatically monitor network requests. So this is a feature that's near and dear to my heart because on iOS, I implemented that. So let's get started with traces first. The easiest way to define a trace is that it's a performance report between 2 points in your app. So imagine that you have a record and a stop button. And in between those 2 points, you capture a lot of metrics. These 2 points can be anything in your app. They could be anything that you care about or anything that's worth monitoring. It could be something like the time between the user tapping on one of the shoes until they see the full product details page. Or it could be as fine-grained as a database fetch to get a string and display the string. Or it could be as long as the full checkout flow. All you need to do is create a trace object, give it a name, start and stop it, and the name becomes the context. So now when you're looking at metrics, you understand what was happening at the time in your app. In terms of metrics, by default, you get the trace duration, so how much time has passed between the start and stop. And essentially, a trace is a timer, but it's more than that, because you can attach custom metrics using our counter API. So think of any example of countable events that are relevant to the performance of your app. How many times you stat the file system, how many times you call the GPS, how many times you drop a frame, how many times you make a network call, so on. For any one of these events, you can give it a name and count it. And we'll tell you about these events in the console and report them as custom metrics attached to your trace. So this gives you an idea of how to implement your own traces and counters, but even if you don't do any of this, and all you do is install the SDK, you get a few out-of-the-box traces. And the most important one is app start. So this is the time between the app code starts loading until the app becomes responsive to the user. And we also have a trace that monitors the foreground session, so when the app is presented to the user, and we have another one for the background. All right, so network is just as simple. You don't need to write any code. Out of the box, we will monitor HTTP and HTTPS requests that your app makes between the time that they are sent from the app until their response is fully received. And when we do that, we report several metrics, including response time, requests and response payload size, and success rate, where success here means any request that comes back with an HTTP code that isn't a 400 or a 500. And for any of these metrics, they can be sliced and diced however you want, by device, country, OS level, and so on. And this is really helpful to eliminate variables when you're trying to understand the contributing factors to some of these issues. So the best way to explain this, I think, is if we got back to Jane and talked about how she used performance monitoring to, over the course of 4 weeks, to get rid of a lot of performance issues and fix them very quickly. So we're going to do this by tracking what she does on her iOS app. So far, the only thing that she's done is installed the SDK and used the out-of-box capabilities. So she hasn't written any code yet for performance monitoring. So week 1, Jane completes the first major release. So far, she's been building a bunch of experimental releases, and this is the week that she's decided that she's going to release version 1.0. It's always a really tough decision. So the e-commerce app right now only operates in US and Canada. And the app launch isn't going so well. We have a bunch of 2-star reviews, and the complaints that we get from users seem to be about app start. It's just taking too long. Some people are getting frustrated and are just giving up on the app. So what she does is she jumps into the Firebase console. She checks out the brand new performance section. I have a fancy laser. I don't know if you can see this, but I had to use the laser one time. So there's a brand new performance section in Firebase. And so the first thing she sees is this dashboard tab. So this here gives you a high-level data view for both traces and the network aggregated for the app. And keep in mind, she hasn't written any code yet. So all the data you see here is out of the box. So let's take a look and see what we see when we look at the first cards. So the most frequent traces in this case are out-of-the-box ones, which makes sense. App, foreground, background. And app start has a median latency or duration of more than 3 seconds. And that does seem to be a little bit high, and we'll get back to this, but we can keep going. So the next one is network success rate. And we always want this to be 100%, but when we start seeing 400 or 500 errors, that line goes down, and if you actually hovered over, you can see the individual data points and what it looked like on any particular day. So the next card here is response latency by country. And since we only have data from the US and Canada, we see that on the map. And if you hover over the country, you can see that the US is 1.02 seconds, and Canada is even less than that. So everything looks fine here, so we'll keep going. So the next one is a card that gives me the breakdown of network volume by MIME type. So since it's an e-commerce app, most of it's images, and that makes sense. There's nothing here that seems unusual. So the last card gives me, which is on the bottom here. I had to use the laser one more time. The last card gives you a comparison of app start's version over version. And now this is interesting. You can see that with version 1.0, which is the latest release, it has a much higher app start duration than the previous ones. So what you see here is the dark dot is the median, and then when you move the mouse around on that blue line, it's the range of percentiles. And so you can, if you hover over it, you can see that the 95th percentile is just underneath 7 seconds, which is very high. And this is useful information, and so far is a strong indication that something went wrong in this version. But how do I know that there's no other contributing factors? If I click on View App Start Duration, I get a breakdown of this metrics by different dimensions, and I can see that I can see how app start duration compares version over version. And not just version over version, but version over version with different devices, country, and so on. And you can try to see if there's anything that stands out. So you see the median, you see the percentiles around it, and you already know that 1.0 is a lot higher for app start duration. And if you look here, you can, like at the devices, you see iPhone 6 is a little bit higher, but that's kind of expected. It's slightly older device. It's going to be slower. So if we just keep going, you see the country, it looks comparable. They're pretty close. OS level looks comparable, and so on. So Jane knows that to fix the app start issue, she has to do something about version 1.0, and that's enough information for her right now. So she jumps back into her code, and she looks at the launch method and realizes that there's this blocking call to load a bunch of cache items. And there's no good reason why that has to be made that way. So she switches this to an asynchronous call, and that takes care of the issue. So she releases version 1.1 of her app. And this is the end of the first week. And the second week is pretty interesting. So this is the week that we decide to expand our operations to India. And this means new users and new behavior, and so the first thing that she does is get back into the console. And she takes a look to see how things are going. First, you can see the app start. It looks like the median's down, and that's a good sign. If you scroll down, you can actually see that version 1.1 has a much shorter app start. And so it looks like we fixed that issue, and that's great news. The bad news is that now we have some data from our users in India, and it seems like network latency is very high. And if you hover over it, you can see a 7.2 median second latency, and that's definitely high. So how do I investigate this? So if you click on the network request tab, you see a bunch of URL patterns. You see calls to analytics service, image fetching URLs, something for adding something to the cart, and so on. So anytime you see one of these asterisks, it means that there's a dynamic segment in the URL. And it could be something like an ID. So what we do is collapse all these IDs into the same URL pattern. So when you see a metric, it's based on the level of backend functionality, as opposed to looking at individual URLs. So for each one of these URL parameters, you get the response time, success rate, and you get how many requests you've actually collected. And if you look closely, there's a couple of warning icons here. I'm only circling on that side. I should be fair and circle on this side too. So if you hover over them, you can see one of them is complaining about latency. It says that we recommend to keep response time under 2 seconds. And the other one says that the success rate is below 90%, and that's problematic. In fact, we can see that the success rate here is 87% for the checkout service, and that's unexpected. So we need to investigate this a little bit more. So I'm going to go click on that URL. And you get a bunch of metrics, just like before. You get response time, payload size, success rate. If you click on View More, you get a breakdown of the dimensions like we saw for the app start trace. But you get a card here that gives you a breakdown of 400 and 500 errors. So this way I can understand what's caused the failure. I see that approximately 12% of failures, the majority are 500, including 500 and a little bit of 502 and 503, but vast majority 500. So if you scroll through, you can see the other dimensions, see if anything stands out. But everything looks pretty evenly distributed. So if I look at country, I can see that these failures are all coming from India. And the success rate is 0. So this is pretty much what I need to know. We have 500 errors, and they're only happening in India. So if you switch over to the overtime version of this data, you can see the same metrics by time slice. So you can see how they happened over the last 30 days. You can see that the 500 errors spiked around the same time that we released the app to India. So this confirms the theory that I had, which is great. So now we can go back to that network tab and look at the other warning that complains latency is too low or high. I think this also has something to do with my users from India, because I didn't see this before. So here, any of the dimensions that you see, you can filter by many of the other dimensions. So in this case, we chose to filter it by country, and we chose India. And you can see that the image service is way, way higher. The median's about 20 seconds, and that's something that we obviously need to fix. So this is a lot of information, so we can get back to the code now. So we look at that 500 server error. And in this case, we realize that the Indian locales in the app are not correct. Hindi, which is the predominant locale in India, was misspelled, so that's an easy fix, so we go ahead and do that. And then for the slow response time, we realize that we're getting images for those products using our own service, and the server sits in the US. And this was fine for North American users, but it's not going to work for Indian users. They're just too far away. So we switched to Firebase hosting, which gives you a CDN and takes care of things like edge caching. So she puts the assets on the CDN, changes the URL, packages up all of these changes into version 1.2, and that's the end of week 2. So week 3. Now we're seeing things starting to get better, so we're seeing our 4-star reviews coming in, but there's one issue here for this Indian user. His name is Nitin. He seems to be a bit upset that he spent 50 megabytes of his data plan on the app, and data is expensive in India, so this is kind of a big deal. We want to see if we can try and help this user. So Jane realizes that we have this card here that gives you a breakdown of your network volume by MIME type, as I showed earlier. We already know that the majority of it is images, and it hasn't really changed, except it's maybe even gone up even more images. And she realizes she's never storing these images locally. She has no caching logic. And there's no good reason that we need to go to the CDN every time and fetch these images, so she wants to implement the caching logic, so let's switch back to the code. So the first thing she does is figure out the cache size. And this is like not a great way to do this. She's initially coding it to be 20 megabytes, but what if you want to change it in the future? Like maybe you want to make it 25 megabytes. So you would have to change it, release a new version of the app. It's not great. So she uses remote config. She sets up a parameter in the console, sets a default value of 0, names it cache size, and moves on. So now instead of hard coding, she's just changes the code, so she reads the value from the remote config and changes the cache size, so she can change the cache size whenever she wants, without shipping a new version of the app. So she adds the logic to do the caching on the device, and that takes care of the implementation of that feature, but she needs to monitor this. So she creates a custom trace. She names it image fetch. She starts it before the caching logic and stops it after. And then within the caching logic, she does a couple of things. She creates a counter called cache hits, and then that gets incremented whenever there's a cache hit, and she does the same thing for cache misses. She packages up that code, ships version 1.3, and that's the end of week 3. Now, week 4, we want to check to see how everything is going. So Jane jumps back into the console. And we can see that India is not slow anymore, and that's great. But we did just add a brand new trace. So let's go look at that. So we'll click on the Traces tab. And we see that the traces that come out of the box, but we also see the one that we just created. So you can click on that and get the duration metric, which you always get. But you get the counters here as well. So cache hits and misses are there, but as you might expect, they're all 0 because if you recall, we set that remote config parameter to 0. So she goes, edits the value, changes it to 20 megabytes instead. She updates it, publishes the changes. She lets a few hours go by so that this change is propagated to the users of her app, and we have enough data to look at. And then she comes back. This 0 for cache hits isn't 0 anymore. I'm starting to see cache hits. And in fact, if you switch to over time, you see cache hits going up, cache misses going down, and that's the direction that you want. And this allows her to tweak the value to see if there's a more optimal value without ever having to ship a new version of the app. So people start noticing her updates. Jane is very happy. Performance is getting better. They start sending amazing reviews, and that's exactly what you want. So let's take a look at some of our partners. So this example is an app that's based out of China. WPS Office is a popular office productivity app, and they use Firebase performance monitoring. Using the network monitoring feature, they realized that one of their ad banners was taking more than 2.4 seconds to load, and that was a lot longer than they expected. So they optimized this, increased the performance by 20%, which increased the click-through rate by 3 to 5 times. And all they had to do was install the SDK, and they got this huge increase in click-through rate. And I'll give you two more examples. Kaskus is a chat app based out of Indonesia. They use performance monitoring, and realized that one of their biggest performance bottlenecks was opening the chat window. It took 0.5 seconds, which was also much longer than they expected. They optimized that. Because of that, their user experience is a lot better. This is one of our product manager's favorite examples. Isla Sena is a video app based in Turkey. And even though they haven't been using performance monitoring for very long, they've already customized the code paths for the users based on the combination of device and OS level. And this is the kind of thing that would have been really difficult in the past, but because of the insights you get in the console, you can do this kind of thing. So we've been working with large and small app developers around the world. And what we've made, and to try and help make sure that what we've made is useful and valuable. So we talked about app quality. We talked about why it's important, why we deeply care about it in Firebase. We talked about the test side of things and using Test Lab, and we talked about stability and Crashlytics. And then we took a deep dive into performance, and we saw how Jane used it to turn her app around and go from poor reviews to much better reviews. So it's been out since I/O, so please check it out. And just before we end, I have 2 requests. One is go to firebase.google.com, check out the documentation on Firebase performance monitoring, get a feel for it, and then get back to us. Let us know what you think. Most of our team is available in the Firebase Slack room, and you can find us at firebase.com/support. And you can chat with us there. And right now, I'm going to go to the Firebase booth. If you have any questions about Firebase, please come talk to me. Thank you very much.